Hey, my name's Tom Blackwood. I'm the Director of Retail Operations for Buena Vista Winery, and I'm here with Dennis Cox from RDC Construction. Dennis and his crew has been a big part of our restoration, and they have been in charge of the center core drilling and the retrofit of the historic cellars behind us. Have a few questions for Dennis here. We'd love to get some answers. And so, welcome Dennis. Thank you so much for joining us.
Thank you.
Can you describe how you developed the dry core method? I know that previous coring was wet core, so tell us about that.
Well, in Long Beach in 1989, an engineer called David Breholtz out of Lomita, California, had an idea to develop a wall strengthening system because it was just coming on board the earthquake retrofit system of California. And they were tagging buildings, and LA County was one of the first counties to tag buildings that were preferable to unreinforced brick masonry. And the beginning of the job of the Episcopal Church of Long Beach, they had another coring operation that was drilling wet. And what proceeded to follow were monumental problems with the water introduced to masonry, the mortar. The joints in the mortar in the middle of the wall were being washed away. And the building wasn't drying out. That was the two problems. They began to pour a similar material, and they couldn't stop it bled out, they didn't clean it, and it was kind of a failure. And I just happened to be on the project at the time. I was doing much like this job, the epoxy, they weren't epoxy bolts at that time, but diaphragming the floors. I was a framing contractor at that time, and I did the small cores. And I just thought I was doing dry drill, small cores. And so it just dawned on me, and I brought it to their attention. So the next project, we decided could we develop a dry drilling system in the Bank of America building, which is in downtown Long Beach also, done by the same engineer. And that's where we started to perfect the dry drilling method in 1990 approximately.
Great. Yes, I know it was a real issue with our building trying to keep it dry inside the walls, and I know that you experienced some wetness in certain walls, and that definitely slowed you down a little bit.
Right. The bedrock has been weeping from the hillside, and the top, I'm going to say the first 8 inches or 10 inches was kind of corroded. But as we got into the bedrock, the bedrock started to dry, but the top part of the bedrock was wet. But once we got down into the bedrock, it was dry because it's bedrock. It's not conducive to dry drilling. Water is not conducive to the polymer, and it's not conducive to the dry drilling method. It creates that's how we vacuum up the dirt, is through a double line system. And so it created a real hardship on the backside, and the mortar and the areas that have been wet for many years, which is going to be corrected.
Correct. Yeah. No, we're working on that, and it's great. Now, talk about a little bit about the center core. Why the center core method is a great method for stone masonry buildings.
Well, stone masonry and brick buildings, both. What it does is it creates an in-plane and out-of-plane shear factor. And what it's doing is it's strengthening those areas that are unreinforced, hidden. It's a hidden system. It's in the middle of the wall. So it allows the building to be replicated the way you look at it. Yes, some tuck pointing has to be done, but what it's going to do in that earthquake is those floors being diaphragmed along with the roof are going to create a box. And with the core being down the middle of the wall, it's hidden. It reinforces every nook and cranny that we can possibly try to get into that core area. And with the bolt connection at the floor lines, it's going to create a box. And when the earthquake hits, it's going to rebound. So this material has rebound. And the reason the center core method was even better than what we expected was when we started experimenting with the polymers. instead of a cementitious grout. The cementitious grouts didn't seem to have any adhesion. They were very difficult to allow bricks or stones to be, you've got a cold joint, and that cold joint created a real hardship in the labs. We did work in Champaign, Illinois, Long Beach State University, and UCI University, along with their engineering departments. And the conclusion was that once the Cinecore method was developed, we needed something that would flow and grab at the same time. And that's how it was developed.
Great, thank you. So is this Bonavista Champagne Cellars, our beautiful building, is this a unique project for Cinecore projects, or is there anything different about this project compared to all the others you've worked on?
This building is a real challenge. What we found with the gentleman, what was the gentleman's name that built this?
Augustin Harasti.
Augustin did something that normal masons did until about the 40s, and that was they took the good stones on the inside and the outside of the building, and they used rubble in the middle of the wall to create that 20-inch airspace. And those stones are approximately 8 to 10, 6 to 10, and 6 to 10. And he said, oh, well, I need this 20-inch wall. So he started putting rubble in the middle of the wall. And that's what we came across. We came across quite a bit of rubble. My other stone building I did that was very similar to this in Preston, Idaho, built about the same time by the LDS. It was the original school for the prophets, they call it, of the LDS Church back in 1860. And same identical thing. We had a cave-in situation, which means that the mortar became silty, and as we retract the drill, we're vacuuming as we go down. We're also pulling all the loose material. And then once we pull the mortar out, if there's a rock happen to be there, the rubble we call it, it also wants to cave in. So we're putting a lot more material back into the wall, which is good. We're getting rid of this non-stone, I call it. And that's the unique challenge of this job, is trying to keep our drilling time down, but at the same time remove all this rubble and create whatever cavern we have and fill it. Just fill it in its entirety. That's the challenge. And so far we've been successful. We've got a couple walls left to grout, and we'll be finished.
Great. So now that you are almost finished with the building, what didn't you know before you started that you know now?
Well, logistics. Logistics of this job, only having this small road, and of course with all the new improvements you're going to create here, it's going to be so great. But we've had, as you know, the wine tasting room has been open, so we've had to be particularly, susceptible to your business, and so you have challenges on a job that we don't want anybody to be offended by forklifts and construction equipment. So we've tried to create the noise problem back there. If we happen to see somebody down the road, we have to, we allow these people to still come and visit the wine tasting room. Business is open. We just have to accommodate the conditions. That, the challenge of the building, scaffolding issues that we had to make sure safety-wise. We have a lot of substance job. We have drillers inside the cave doing their work. We have the tuck pointers. We have the general contractor and his crews. So you have to facilitate, and what happens is, that's what happens in a job like this. You have to make sure that everybody can still do their work, and at the same time, keep it a little harmonious. But make everybody flow with what the objective is, to do it in a timely fashion, and everybody still make their profit margins. That's the whole point. You're in business to make money, but some things you don't count on when you come onto a job condition. And as you know, as I just explained, that's pretty much it.
Well, thank you, Dennis. It's been a pleasure talking to you and hearing the stories, and this whole project is so exciting for all of us at Buena Vista, and we're glad that you're strengthening our building and making it safe for the public to visit, hopefully very soon.
Well, I enjoyed the project. It's been a challenge. It's been one of my more challenging projects. I'm glad we bring it to a successful conclusion. I'm glad we're getting it done. I'm going to come back here with my wife, and this next time I come back, I will be enjoying your wine tasting room and as a visitor, and we can walk into the caves hopefully and see what we finally completed. You know, that's the one thing I like about doing these historical jobs, is that it's rewarding, very rewarding as far as my projects, and at the same time, this is my 100th masonry project exactly. Over 22 years of doing this work. It's kind of exciting, my 100th job. So.
Well, no, that is great, and classic irony at Buena Vista. So many things are tying together. Count's 200th birthday, your 100th job, and truthfully, the almost 150th anniversary of the Champagne Cellars being built. So it's been a great year. 2012 is going to be great for Buena Vista. And again, Dennis, thanks for your time.
Thank you.
It's been a pleasure.
Thank you, Tom, for all your cooperation. Appreciate that.
All the best.